So the whole idea about parametric equations is that they are adding another variable t to the mix. So our points are still going to be x, y points, but instead of x being an input into a y function, we now use a third variable t, generally used for time, which plugs into both the x and y coordinates. So first off, just to graph a parametric equation. We're used to the t-chart. Now we're going to have a 3-column chart. We're going to plug values of t into both the x equation and the y equation. Our points that we plot are still going to be xy coordinates. The whole idea is it's not x that affects y, though, it's t that is the input to both the x function and a y function. So we use t because the main reason for parametric equations is to be able to analyze something in terms of time. So t generally represents time, and then x is your horizontal aspect as normal, and y is your vertical aspect. So now, for many of these, you're going to be given an interval in which t will be graphed. Sometimes it's negative infinity to infinity. That means t can be anything. In this case, we're saying that t can be, so our time can be between -3 and 3. Notice these are hard brackets. Remember from earlier in the year, that means that -3 and 3 are included in our graph. So when we're picking numbers for our table, we'll just start with -3 and plug in values all the way from -3 to 3. So now we have our equations. We're just going to plug these values in. So first we'll go through the x's. -3 squared is 9. -2 squared is 4. -1 squared, 0 squared, so forth and so forth. Now to get our y's, we'll use the y equation. 2t plus 3. So when we plug -3 in, we get -3. If we plug -2 in, -1, so forth, till you have all of your values. So again, if you're not sure where those numbers came from, we use the x equation, plugged our t's in. We use the y equation, plugged our t's in. Now we have coordinates that we can graph. So this will still follow a normal xy coordinate graph. Just plot our points like we're used to. So we have 9, -3, 4, -1, 1, 1, 0, 3, 1, 5, 4, 7, and 9, 9. Now notice this is in a hard interval, so this graph is not going to continue forever. It started down here at 9, -3, built going up the other way, stopped at 9, 9, and there's your graph. So another thing that's going to be important with these graphs, since a lot of times they're used for time, we notice we started at -3. So this graph, if we looked at the motion that happened from -3 up to +3, it started down here at the bottom, and it followed a motion around up to the top. So the main application for parametric equations deals with modeling motion, because we have a t value that represents time, and then we can plug that in to find a horizontal distance, a vertical distance after so much time has passed. So that first slide was all about how to graph a parametric equation. This second slide is about how to find a rectangular equation from a given parametric. So a rectangular equation is an xy equation. That's what you're used to. So the most basic way to find a rectangular equation is to just solve for t in one of the two equations, either x or y, and then plug it into the other equation. So now it doesn't matter which of these equations we use. In this case, I would look at, you generally don't want to take a square root to solve, because when you take a square root, you suddenly have to deal with the plus or minus. So like for this case, if I were to solve for t in this first equation, I'd have to take a square root of both sides. I've had a plus or minus x that makes things more confusing. So I'd want to take this y equation, solve for t. So we have y minus 3 equals 2t, divide by 2, we get t equals y minus 3 all over 2. Now we just take that, plug it into the x equation. So we have x equals y minus 3 over 2 squared. So to find the rectangular equation, just solve for t in one, and then substitute that into the other. So now another phrase for this, you'll either see find the rectangular equation. This is also called eliminating the parameter. These are called parametric equations because t is considered the extra parameter into the function. So if you ever see the directions eliminate the parameter, that means get rid of the t value, meaning put it just in x and y again. So now a way we can finish simplifying this, over here, we go in square top and bottom. So we have x is y minus 3 squared all over 4, which we could also write, if we want to get rid of that fraction, as just 1/4 y minus 3 squared. Now there's really not much more we can do with this. If we take a square root, that turns into a plus or minus situation, so we want to keep it as is. It might seem weird that it's an x equals instead of a y equals. Our next unit, though, you'll see this is a general formula for a sideways or horizontal parabola. So at this point, we'll just stop there. This is our rectangular form for that equation. Now, as I mentioned earlier, this is the most basic way to eliminate the parameter. The majority of the time, this will be your method. Just solve for t in one equation, plug into the other. Tomorrow, we will talk about when this actually overcomplicates things and a couple other methods you can use. But moving forward on the next slide, there's 4 graphs for you to draw the graph and find the rectangular equation. This method will work on all 4 of those. So complete those in your notes and I will check them tomorrow.